Hi, you are welcome to Maitakama Online Computer. My name is Stephen Ngbo Maitakama, the Director of Programs Maitakama Online Computers. In today's lectures, we'll be taking you on electrical circuit breaker. Electrical circuit breaker. In the power industry, what do you know, or what do you think a circuit breaker is? In the power industry, the power system. What do you think a circuit breaker is? So I will take it this way. A circuit breaker is an electrical device that operates automatically and can make, carry, and break load current at normal and abnormal conditions. I repeat, a circuit breaker is an electrical device that operates automatically, can make and carry and break load current at normal and at abnormal condition. That means at normal and at false condition. It's capable of doing that. And what are the components of a circuit breaker? The components of a circuit breaker. A circuit breaker has the following components. A circuit breaker has a breaker pole. It has separable contacts. It has CB operating mechanism. It has closing and tripping coils. And some breakers have interrupter heads. So there are so many other auxiliary components that are attached to a circuit breaker. But this is the one I can mention as the main components for now. Then what is the function also of the circuit breaker? The circuit breaker functions this way. It is capable of restoring a circuit. Then it is also capable of interrupting a circuit. Why is it done that way? It is designed in such a way that there's always an arc that accompanies when the operations of a circuit breaker. When you open, the contact will act, and when you are trying to close, the contact will also act too, especially if there is supply. And if the arcing is not controlled, it could bring about the explosion of a breaker, because it can ignite fires, arc can ignite fires, and the combustion will definitely take place inside the breaker, and it will lead to explosion. That is why a breaker needs the quenching medium. And we have isolators too that can make and can break a circuit, but they don't have the facilities of interrupting of the arc. So they can't quench the arc, they can only interrupt the circuit, they can open and close the circuit, but then they don't have a means of quenching the arc that will break place. But a circuit breaker has that one. So, and the circuit breakers are classified based on the quenching medium. That based on the quenching medium. And the quenching medium of the circuit breaker is as follows. We have oil for a quenching medium. We have the air blast, which is also a quenching medium. And then we have gases also as quenching medium. So the oil circuit breaker has oil, and the contacts of the breaker are immersed inside the oil, so that when they are open or when they are to be closed, with the supply on, you are interrupting or you are closing, definitely the arc will take place, and it will take place inside the oil. And the oil is a very poor supporter of our combustion. So the arc will just quench there, and nothing will happen. There will be no explosion. There will be no combustion, because the arc will just quench there. Then we have also the air blast breakers, which uses about 15 to 30 bar. Is compressed. The air is compressed. So when the contacts are to be open or to be closed, there will also be an arc. But the air blast, because of the force, the pressure inside the air, it will blow off that arc, and there will be no effect of that arc. It will definitely be quenched. And then equally we have the gas quenching medium, and especially the sulfur hexafluoride, which is called F6 breakers. So the gas is used to quench the arc. It's a compressed gas, which is F6. It doesn't support combustion, because the outer shell in chemistry, the outer shell of an F6 gas is an octet level. It has 8 electrons at the outer shell, and the moment you have a gas that have a outer shell of 8, it obtain octet level. It doesn't support combustion easily, and F6 gas is very, very perfect in that. It doesn't support combustion the moment it is pressurized and placed inside. So when the opening takes place, the opening of the breaker takes place, or the closing of the breaker takes place, when there's supply, the arc will appear, but the F6 gas, which is under pressure, will now quench the arc. And the disadvantages of the oil circuit breakers, most of them are phased out now. It was as far back as 1980, 1981, 82, 83, and 84, 85. In fact, oil circuit breakers were in existence, but it seems most of them have been phased out now, because most of the stations these days are using F6's circuit breaker. Then we used to have vacuum. Vacuum also doesn't support combustion. The moment the breaker is a vacuum circuit breaker, when you open the contact of the breaker, or close the contact to the breaker, there will be arc, but the vacuum doesn't support the combustion, so it has no effect. So, but then, what are the advantages? Why are oil circuit breakers and air blast breakers and vacuum circuit breakers, why are they being phased out these days? The oil circuit breaker, there's what is called, it's made out of hydrogen and carbon. We call it hydrocarbon components. It's an oil that has hydrocarbons. And in the course of time, during the arcing, the opening, the hydrogen and the carbon disintegrate. They break into hydrogen and carbon. So there will be accumulation of gases inside the circuit breaker, and also there will be carbon deposit. Carbon is not completely an insulator. It conducts a little bit. It has a little conductivity in it, but when it becomes matte, it conducts, and it can cause an explosion. It can breach the metal body and breach the contacts of the breaker, and that will lead to explosion too, because the carbonized hydrogen breaks into carbon, and the hydrogen breaks. The hydrogen is gas. It's contained in the circuit breaker. Well, also the carbon, which is a poor conductor, deposit inside the circuit breaker, and as in the course of time, when the deposit becomes much, it can cause a short circuit. So that's the disadvantage, and these are the reasons why the oil circuit breaker is being phased out. Then we have the vacuum. The vacuum too, there's no air inside, but mark you, for you to make a particular thing to be in a vacuum, that is no air at all, you need a proper seal, and that means from time to time you need to be changing the seal, and if it is not properly changed, then air will enter, and air supports combustion. So the moment the air enters mistakenly, the seal is not properly sealed, or the operators on duty did not observe it in time, it is easy for ordinary air to penetrate into that vacuum. So, and it will definitely support the combustion. and the breaker, the possibility of it exploding because of the arc is very, very high. Then you will come back to the F66 gas, which is now being used widely. F66 circuit breakers being used widely. Is that the moment it is pressurized and the seals are okay, it doesn't support combustion. It quenches the arc very fast, and it has pressure meters, which are either measured in we measures the pressure in the breaker. So we have maximum, we have minimum, and we have the local. So when it is normal, the pressure gas measure the gas, then you can see it. The analog meter can show it vividly when you go out for inspection. That's the pressure meter. You will see the green, which is tolerable. That is within the operational value. Then, if you see it pointing at yellow, that means it has dropped. We now have low F66 gas, which is not normal. You can begin, but the breaker will still, it can still be operated even with the low F66 level. You can see that one vividly when you are checking the gas pressure meter. Then, when you see red, then that means it has gone into local. There will be no mistake of you closing that breaker, of which the gas will not be effective enough to quench that arc. And so the breaker will not even close because it will lock out. The counter that's supposed to, the supply counter that's supposed to come in to the breaker, that is the closing coil or the opening coil, for the breaker to operate, will be locked out. So there's no how you can make a mistake of closing and it will respond. So the arc will not even be generated because there will be no operation. The operation will be locked out completely. So it has a lot of advantage, and it's easy to get a gas and change, and which is not constantly. But with the oil, as time goes on with the constant operation, it carbonizes, and so that means the rate of changing oil, for the quenching medium oil is higher than that of the F66 gas, unless if there's leakage, and leakage can now be detected easily because the pressure meter will now tell you whether you are at a normal level, operational level, or is going down low level, low F66 gas, or it has local. You have the meter will now tell you, and you can equally report to the appropriate department for the gas, that is the EMD, or whichever department is has the authority to stop the gas. You write your report and give it to them, then they will just clear that one. Then we have sometimes the breaker, when it's meant for, it's an automatic device that can trip at fault. You can close it at normal, and we have auto reclosure too, relays that can make a breaker after tripping, then it closes back on its own based on the auto reclosures settings. So if a breaker, we have what is called breaker failure. Sometimes faults develops. If there's a fault and the relays operates in lines with the fault signal that comes into it, if the breaker did not operate, we call it breaker failure. So what do you think can cause a breaker to fail to trip on fault, or even fail to open when you give it a remote control signal operations? What do you think can cause all these problems? So they are you have a lot of numerous problems that can result to a breaker failing to trip during fault conditions. So the few possible causes, I'm going to release the causes in details in my notes, but in the video I will just mention only but a few. So we have the causes can be this way. The trip coils are faulty. Maybe they are burnt. Trip coils could be faulty. There could be an open circuit that is on the tripping circuit. There could be a burnt fuse that the tripping circuit is faulty. Then we can equally have that is the open circuit as a result of a burnt fuse. Then we can also have a short circuit problem on the tripping circuit. Then other failures could be low battery or no battery supply. So the 110 volts, the supply is supposed to flow into the trip coil for it to trip during the fault. If there's no supply which is faulty, maybe due to bad batteries, the breaker will not trip, and it could be as a result of faulty batteries or faulty battery charger, which is supposed to charge the battery to have a very good voltage level that's supposed to operate the breaker during the fault. So then we could also have mechanism problem. That is, the breaker operating mechanisms, or maybe faulty. Maybe they stick together, and when the signal comes for it to operate, the tripping coil is okay, but the mechanism is not responding. So definitely the breaker will not trip at fault. Then we also have if the mechanism are okay, and the trip coil is okay, and the tripping circuit is also okay, and the battery is also okay. That latch that normally release the springs for the operation to take place, if it's stick, that is talking, if it's stuck and it cannot lift up the trigger, then definitely the breaker is not going to respond to the trip signals. Definitely the breaker will remain in closed position, and that will be very, very hazardous. So the breakers can also be described based on the operating forces. Before a breaker will operate, there must be a force, like a human being, that will push those contacts open. So what are the forces, or push it close? What are those forces? The forces could come from this spring force. This can be spring charge, and the force is developed and keep inside the spring. So when a command is given, a signal is given for opening or closing, then the spring force will now open or close that breaker. Then we now have the hydraulic pressure, which is oil. We have pumps that pump the oil and keep it under a very high pressure. It's sometimes measured in bar, sometimes it's measured, the pressure is measured in Pascal, sometimes measured also in bar. So if the hydraulic oil is much compressed to a very high pressure, that pressure is enough to open or close a breaker. Then we have the pneumatic force, which uses air. Air is compressed, and a lot of force, a lot of pressure is in it. Then when it is released, the force inside that gas and the air can equally open the breaker. That is pneumatic. Air is compressed, and the force released during the closing or opening signal, and is capable of crossing the breaker. So this is what we can track for now. The details is going to be on the note, and then this is a channel where you can subscribe, and then you can share to others, so that you will be following from time to time. This lectures actually is meant for system operation engineers. Thank you so much for watching. Once again, my name is Ngbo, Maitakama, and we'll meet in the next lectures. Bye for now.